All right, so from whence we last left off, we basically have a operatable game. It's pretty much working. Um, what I want to do is refine one of the game mechanics, and that being his um, jumping, more or less. And this is going to be more complicated than pretty much everything else that we've done by far, and it'll be the most complicated piece of code that we write in the whole course, but I do want to touch it just because it's kind of powerful and you can use it for all sorts of things. Because one of the things that happens, and I'm sure you've noticed this when we play the game, is that when we go to jump and stuff, it's somewhat inconsistent. See how I jump that high and then I only jump that high. Now it's inconsistent, right? So what I want to do is make it less inconsistent. It's also inconsistent when I go to jump on him, and the jump feels just, I don't know, a little bit floaty, if you will, right? So we don't have much control over it because we're just applying a force, and wherever the physics lead, that's where it ends up being. And if you feel it, it just doesn't feel quite like a normal jumping game. Now, you could totally do this, and I've noticed that more and more games, this is what the jump looks like. But if you look at old school platformer games, you're going to notice that the jumps, and ones that have that heritage, like Mario still jumps a certain way. You'll notice that when they jump, they pop up a lot quicker, and then they kind of float down. Okay, that's basically the idea behind it. So anyway, I want to fix that, but right now there's just no control. We can't do that with the physics. All right. But if you were happy with this, this is actually better in some ways than what we're gonna do, because what we're doing now, what we currently have is very physics based, which means that it's much more dynamic. What we're gonna do is we're gonna code him jumping up, and that's where it gets kind of complicated. Okay, and it's all gonna be in one piece of script. So I'm gonna open up the player controller script. Excuse me, and we don't need you. Get over here. Okay. And this is going to be it. Can I zoom in a little bit? Okay. Okay. So first thing I want to do before I do any of the rest of this is I want to set up something for our ground detection. Currently, the ground detection is working by having this object, this ground check, and it senses whether we touch the ground. But that's part of the reason why we have the inconsistency, is because it's based on like its depth and things like that, and it's not working super well. So what I'm going to do instead is use a different system. It's more efficient, and it's useful for other things beyond what we're doing, and that is raycasting. Okay, so instead of using a collision box here, a trigger collider here, we're going to do raycasting. Okay, so the way the raycasting works is it's not going to use the tag. So if I go to my grid and then mid ground, okay, right now we have this tag called ground. It works instead by layers. You have layer masks, okay? And you can see you have these ones here that are already kind of built in, just like, you start off with tags that are already built in. Basically, the raycast use layers. Okay, that's all you really need to know, all right? So what we're going to do is add a new one to this mid ground. We'll just do add layer. And then don't add it to 8, add it to 9 just because, and we're just going to call it ground. Pretty simple. Got to go back again because it's one of those things where it doesn't actually do it. So you'll see that, look at, it's number 9, okay? So we want to add ground to that. And then the other one I want to add is on my actual enemy. So select the enemy here, hit open, and then select the enemy here. The actual graphic, because that's the thing that's going to be, not the graphic, the driver here. You can see it has the enemy tag. I'm just going to go ahead and add another layer. And I'm going to call this one enemy. Okay. Good. Go back to it. Make sure it's actually on there. Great. Okay. Yes. No. This object only. Oh, it's talking about this is its children. Doesn't really matter. Yeah, go ahead and name children. It didn't do these, right? Yeah. Oh, no, it did. No, it didn't do these. Okay, good. This has got it, and yeah, that's fine. All right, then we'll just back out of there. Okay. I want to set those up just so that we can make sure that they're working. All right. All right, so let's go back to the code here. Let's get rid of this. I already closed these out, but we'll close them again. And one thing we're going to need is this. So we have this public rule public bool ground. We're going to need one for ceiling as well, even though we're not really doing anything with that. Actually, you know what? Let's leave that for now. We'll do the ceiling afterwards. Okay. And let's see. I am going to need to add my ground mask. So I'm just going to go after these. I try to lump these together so they make sense. So we're going to go ahead and do a layer. Oops. We'll do private. I guess it doesn't really matter. Private layer mask. And then we'll call it ground mask equals. We got to give it. So basically we're going to make a ground mask, and this is what we're going to test against when we do our raycasts. And we're just going to go ahead and give it its value. And it's kind of weird. It's going to be 1, arrow, 9. And they call this a bit mask. Basically, what we're doing is saying to look up the number 9 and to put that into its slot. It's kind of weird. It's just how they do it. Okay, so let's also do our enemy mask while we're at it. So I'm just going to copy this. Control-C, Control-V. Obviously, Command-V if you're on Mac. And we'll call it enemy mask. And this one was number 10. So 10. Okay, so the enemy mask was 10, that one's 9, and that's how it works. We're also going to be using Raycast, so we'll go ahead and create a Raycast that we can use here. Raycast hit 2D, and we'll just call it hit. And I guess we'll just make that private as well. Okay. All right. So I think that's all I need to start with. All right. So what we're going to do now instead is this. So I already have my bool up here, which I'll probably make that private. What I'm going to do is I'm going to make a function that is going to run on my fixed update. So currently we have update. Okay. So he says this update is called once per frame. That's not inaccurate, but it's not the full description. It's called once per rendered frame, okay? Which means that if your game starts to chug, right? Like let's say it just starts to go, I'm sure you've seen those where the frame drops, the frame rate drops. Basically that means that this stuff will also go slower. But I don't want the Raycast to do that. I want it to be kind of irregardless of it. So we can do another kind of update, and we're going to put it in here. Void fixed update, okay? And the way the fixed update works, it's sort of like update, but instead of being attached to the rendered frames, this is just every cycle. So what that means is that they say it's the physics-based one. It's regardless of what's happening here. And so what you typically want to have happen is that anything that's a physical action that's using physics, you would put inside of fixed update. So for instance, you see how we have this thing like when we add a force and when we do this velocity thing, these are both physics-based. So in a way, they should actually be down here. We're going to leave them alone because for one, we're going to get rid of this one, and this we're actually probably going to change too. But just be aware we would do that. However, player inputs should be on update because the player is going to respond to what they see. So what that means, what you're supposed to do is put, I would somehow get the player input of their left and right and the jump button up here, but then have it give the orders in here is the idea behind it. Okay, so I would actually have to split these up between the two of these. Anyway, we're going to go ahead and what we're going to do is we are going to we'll have a fixed update, and we're also going to make another function here. Okay, so what we're going to do is we're going to say ground, okay, which is our thing that says, well, they're on the ground. We're going to give it the value of ground check, okay, like that. So we're going to make a function called ground check. Now, in the past, we've written void ground check like this, right? We've wrote void. However, void means it doesn't send anything back. It means that it just runs it. This actually needs to send something back because we're giving a value to this. So this has to be equal to something. And in our case, if you look, it's it needs to be a true false. So what you actually are going to do is not void, you're going to write bool. Okay? So all the ones we've always written have always just been void. This one's going to be bool because it's actually going to, it's going to return a value. Oops, not like that, sorry. And then we're going to go like this, and then this will be our function. So basically, we're going to have this ground check function that's running on every fixed update, so every physical frame, every intermittent CPU cycle. It's going to run on that, and then it's going to run this, and then give this its value of whatever's coming out of here. Whatever Boolean, whatever true or false comes out of this is what's going to be punched into this. So this has to return a true or false. That's what this means, okay? All right, so now what we're going to do is run the little bit here. So if you remember, we named a Raycast hit, okay? So now what I'm going to do is use that Raycast. We're gonna run it. So we're going to go hit. We're going to give it some values to say how I want it to cast a ray. So it's part of the physics 2D method, and then it's a Raycast, and then it needs some information. So hopefully if I hover over it, it'll tell me. It's not really. Okay, so it needs a starting position. So our starting position is just going to be where our player is. So I'll just do transform dot position. Okay, that's where it's going to start. Will hover and tell me now? It's not. Okay, that's disappointing. Okay, so it needs a start position. It needs a direction. So I want it to go downward. So there is this here. So oops, not vector 2 dot up. Okay, because there's also vector 2 dot left. I think it's left. Maybe it's right. Yeah. But we're gonna do up. But I don't want to go up, right? I want to go down. So to make it go negative, we just literally put a minus in front of it. And that means go downwards, okay? Then what it's going to need is an amount that it's going to, how far it's going to run, okay? So we're going to say 0.5f. That just means it's a double. It's just another way of kind of, oops, why did I put that there? Sorry. Another way of writing a float, but it's like a special float. It just means that it's higher fidelity. And then we'll write ground mask, because that's what we want to test that we're hitting against. Okay? So basically, this hit is going to be equivalent to this. And now we can test things about the Raycast that we created. Okay? So this basically, this method will shoot out a ray, and in that ray it has to have a starting position, a direction, how far it's going to shoot out. So it's going to shoot out half a unit, and then what is it going to hit against? What am I looking for? In this case, we're hitting against ground mask, which is our ground. Okay. Now we can test basically if we hit something. So we'll do. Where is it? If hit.collider is not null, meaning that we hit something, go ahead and return true. So this is what it's going to return. So you'll notice that if you have something that has a, so like we have a bool, so it has to return a true or false, but if this said like float, we'd have to return a float number, okay? Then we need to have an else, because we have to have, obviously this can be false, right? So we want to make sure, enter, and then we'll just say return false. Oops, false. Okay? So basically it's either going to return true if we hit something or false if we don't. And let's just save it. Let's go back here. And we'll see. Transform. See? Good writing by me. Transform. I'm sure if you saw it, you were probably like, no! Let's see. Alright, and we'll hit play, and we'll see if it works. And it works. Oh, actually, we don't even know that yet. So what I'm going to do now is on the player, I'm going to take this ground check thing here, and we're just going to delete it. I don't need it. And I'm also going to take the ground check script and also delete that. Because now it's not doing anything for us. We don't need it anymore. And we'll hit play. Come on. All right, good. All right, so now it's using Raycast. It's probably not super obvious. I can't double jump, right? Yeah. But it's using a Raycast down, and basically it's shooting a ray downwards. So what I would like to do, just so you could see it here, is I'm going to go back to the script, and I'm going to add something to this so we can physically see it. Because the thing that you'll notice that you can't actually see the Raycast because it's just an invisible physical ray. What we can do is after this actually add something that it's not for any other purpose other than for us to see it, but I want you to be able to see what we're doing. So it's actually a part of a debug.drawRay. Okay, and then inside of that, we need to give it some information. So first thing we're going to need is, a position, and then where we're going and what have you. Okay, so the position is just going to be our position currently, right? So it's the same as what's up here. So it's transform dot position. All right. Then what it's going to need is a direction. So we'll just do minus vector2 dot up again. And what does it need next? Oh, and then a color. So we'll just do color dot red, and then it's going to need how long it's going to be shown for, and then this says that it will be in front of other things. I think that's right. I might be a little bit off. Let's see. So the starting position, the direction. See, this isn't entirely right because it actually needs a little bit more than that. Well, you'll see. So let's go here. I think it's gonna not work. Let's see. Oh, it's not getting upset. Oh, we're not gonna be able to see it in the game either. So we have to do. Let's just do it like this. I'm gonna drag the scene over here. Surprised it's not giving me. Oh, there it is. Okay. So then we can actually see the ray being shot out. Yeah. All right. Sweet. Okay. So we have one issue where we have this vector2 up, but if you'll notice that we have a starting position, we have a direction, we have the color we want it to be, and then we have the last flag here, but and how long it's going to be visible for, which means it's going to be visible for 2 seconds. But there's nothing to say the length, and this is where it's actually a little bit different than what you see up here. You have to do the direction times how far you want to go. In our case, it's going to be 0.5 f. And that will make the ray the correct size. So save that, go back here. And now the ray shouldn't, because I was looking at it, it's like that was really long, but I think it was making it 1 unit long. And currently our ray is supposed to be half a unit long. So this should be more accurate. There we go. Oops. So now I can actually see where the ray is. So you can see it's going this far. So you might notice that with yours, you need to make the ray go longer or shorter depending on like where it's being positioned from. But mine is it's starting from here and then hitting down. So, but this is just for visual purposes. It doesn't actually do anything. It's literally so you can see it. So if you go over here and I change this to like, let's say it's gotta be longer and I make it 1f, I'd have to go down here and also make this 1f, just so that I can see where this ray is going. You try to make these two match up. It's kind of weird that they're not, the syntax isn't the same, but that's just how they do it. It's kind of lame like that, but it is what it is. I'm going to call that good as far as our ground check is concerned. And in the next video, I'll go ahead and we will add some other checkings for the enemy and also for the ceiling.